So today we will read about chemical reactions and equations. Before going on to the topic, we should know what are chemicals. Chemicals means some reactive substances which are generally artificially prepared and purified. So chemicals are what? Chemicals are some reactive substances which are generally artificially prepared and purified. Clear? So now we will come to know about what are chemical reactions. Chemical reaction means what? Basically, it's a process. Chemical reaction is a process where two or more chemical compounds, there are two cases actually, okay, we'll discuss it, where two or more chemicals or any compounds we can write, compounds or elements, okay, they will react with each other and produce some new compounds, where the property of new compounds will be different from the older ones. Clear? And we also tell this chemical reaction is a process in which a single compound will decompose into many compounds. Clear? So basically, if we are defining it, we will define it as it's a process in which elements or compounds react with each other to form new compounds with new properties. Clear? So suppose an example I can say so. For example, if you are taking magnesium and oxygen, when they react with each other, it forms magnesium oxide. Clear? So here we have two elements, magnesium and oxygen. When they react with each other, they will give you magnesium oxide. Now, this magnesium oxide has a different property than magnesium and oxygen also. Basically, magnesium is used in the preparation of crackers and oxygen is a supporter of combustion. Whereas magnesium oxide is used as an antacid. So here we can know that this thing has a different property than the other two things. So basically in a chemical reaction we have two parts. One is the reactant part. This whole thing is the reactant part. And this thing is the product part. So what are reactants? Reactants are those substances which participate in a chemical reaction. Whereas what is product? Product is the new substance that is produced during a chemical reaction. So here we can see one more important information that I must give you, that here one element does not changes into other element. Here magnesium is not turning into oxygen or oxygen is not turning into magnesium. Here just they are rearranged. Like one more equation I can give, sodium hydroxide plus hydrochloric acid. They will give you sodium chloride plus water. Here just sodium and chlorine has come together. They just rearrange this, combined with this to form this, and this thing is combined with this to form water. So here just rearrangement takes place and one element never changes into other element. Clear? So this basic rule of chemical reactions. So how will you know that a chemical reaction has taken place? We'll tell you as, one second. We tell you as characteristic of chemical reaction. How will you know that a chemical reaction has taken place? So whenever a chemical reaction is taking place, it is confirmed that a change is noticed. And that change is called as the characteristic of chemical reaction. So basically we have five changes that we can observe. Okay, the first one is change in, sorry, we can write evolution of gas. Sorry, evolution of gas. Second thing, change in temperature, change in color, then evolution, or not evolution actually, formation of precipitate, we'll talk about this thing. Then at last, change in state. So if any of these 5 changes, any of this, any 1, any 2, 3, 4, 5, इनमें से कुछ भी अगर होता है, you will confirm that a chemical reaction has taken place. Okay. So first, let's go to topic number 1. Evolution. Let me drop all the points, so we'll discuss it. First, let's go to evolution of gases. For example, when zinc granules are added to what? Dilute hydrochloric acid. What will happen? Here I am writing down. Zinc chloride is produced, and along with that, hydrogen gas is produced. So the topic is evolution of gases, and here one example I can tell you that a gas has been evolved. As the gas has been evolved, I can tell you that this reaction has taken place. So wherever you find such equations, you can confirm that a chemical reaction has taken place. I am writing down the formulas. Zinc plus dilute hydrochloric acid will give rise to zinc chloride plus hydrogen gas. As the gas is evolved, we can note down that this reaction is complete now and has taken place. This is just an example. Other examples I will give you by notes. Second one, what we are talking about, second one, formation of precipitate. Formation of precipitate. Okay. First, let's know the first point is the second point. Okay. What is precipitate? Precipitate means a solid, insoluble substance which is produced during a chemical reaction. ऐसा कोई चीज जो एक solution में ना मिले, mix ना हो, that is called as a precipitate. Okay. So for example, PbNO3, lead nitrate, lead nitrate when reacts with potassium iodide, this will give you lead iodide plus potassium nitrate. Again I am repeating, when lead nitrate will react with potassium iodide, this will give you 2 more compounds, that is lead iodide and potassium nitrate, where this compound is a precipitate. It does not dissolve in the solution. Okay, you can easily observe that as we observe it because it is yellow in color. So we write out it as a yellow precipitate. Clear? Okay, one more example I can give. Barium chloride plus sodium sulfate. Okay, this gives you barium sulfate plus sodium chloride. So this is also a precipitate which is white in color. So I write down here white precipitate. So here we have two equations where precipitate is being formed, and if the precipitate is formed, then we are getting confirmed that the chemical reaction has taken place. Okay, now we'll go to the third topic, that is change in temperature. What do you mean by change in temperature? Sometimes, if suppose a reaction has taken place, and if you when you have the reactants and you put it inside the test tube, you must touch it first. You'll feel the temperature is quite normal, but after a while, for 5 minutes, when you touch the bottom of the test tube, you'll feel temperature is being hiked by some degrees. So there's a change in temperature. So basically, change in temperature has two kinds of reactions, where one is exothermic reaction, other one is endothermic reaction. So here, in exothermic reaction, what happens? Heat is produced. Heat is produced. So there is a rise in temperature. In such kind of reaction, in exothermic reaction, there is a rise in temperature. But in endothermic reactions, heat is used up. It is used. So here there is a fall in temperature. There is a fall in temperature. So we have two kinds of reactions here. One is exothermic, where the temperature rises, and the other one is endothermic, where the temperature falls down. So let's go for the example. Very easy example we have here. Calcium oxide plus water. When both of them react, it will give you calcium hydroxide plus some amount of heat is produced here. Clear? What is there? So only heat is produced here. So basically, which kind of reaction this is? This is a exothermic reaction. This is a exothermic reaction. Well, I can give you another example of endothermic reaction. Barium hydroxide BaO2 plus NH4Cl. So ammonium chloride. This will give you barium chloride plus ammonia plus water. When you will, before mixing up the reactants properly, if you touch the bottom of the test tube, you will feel in this reaction, you will have the normal temperature. After the reaction has been done, if you touch the bottom of the test tube, you will feel it is quite cool. Means the temperature has fallen down here. So this is an example of endothermic reaction. If you do the same procedure with this one, first if you touch it, you will feel the normal temperature, but after reaction, if you touch it, the bottom of the test tube, you will feel the temperature has risen. You will feel quite hot. So that's the exothermic reaction. Clear? If any doubts, tell me afterwards. Okay. I'm just giving you some simple examples. Your theory part and other remaining tricks, I will give you the notes. If you have any further doubts, do ask me. Okay. Okay. So the third one is gone. Now let's come to the fourth characteristic of chemical reaction, that is change in color. So sorry for the delay. So here we have a change in color. If there is a change in color, so we will know that there is a chemical reaction. Okay. Previously I have given you the example of lead nitrate. Okay. Lead nitrate plus potassium iodide gives rise to lead iodide plus what potassium nitrate. So here there was a color change, a yellow color came here. So this one can be an example of color change. One more example I can give you. Okay. Let's put up potassium permanganate. Okay. Potassium permanganate MnO4 plus potassium permanganate plus citric acid. That's what might be citric acid will give you a reaction of permanganic acid. Permanganic acid plus potassium citrate. Potassium citrate. So in this reaction, first the potassium permanganate, I will give you the equation. So let me give you the equation first. KMnO4 plus citrate is C6H8O7 will give you HMnO4 permanganic acid. There is citric acid plus potassium citrate means K3C6 H5O7. Okay, this is a question for you. So potassium permanganate is purple in color. So this is purple in color. Sorry. This turns down into colorless. So here is the chemical change taking place where the purple color is changing into colorless. So this can be an equation or example of chemical reaction. The last one, the change in state. Very simple equation to do that. There is no equation actually. Fifth one, change in state of matter. Change in state of matter. What is change in state of matter? Basically, when we have a wax and we provide heat to it, what happens? It melts down. Yes, no. But is a chemical change taking place. The wax burns to provide water and carbon dioxide. Means this solid wax changes into liquid and gaseous form. So basically, I have given you a bit of idea, basic idea about what are chemical reactions and how will you know that chemical reaction has taken place. If there is a evolution of gas, I have given an example of zinc and hydrochloric acid where hydrogen gas was being evolved. Secondly, formation of precipitate. You know what precipitate is, I am telling you again. It is a solid insoluble substance which is produced during a reaction. I have given you the example of lead nitrate plus potassium iodide gives you potassium iodide and lead nitrate plus potassium iodide gives you lead iodide and potassium nitrate, where lead iodide is the yellow precipitate. Okay, the third here, change in temperature. So what is the change in temperature? There are two kinds of changes. When the temperature rises, that is exothermic. When the temperature falls down, there is endothermic. So for exothermic, I have given a very simple example of calcium oxide plus water gives you calcium hydroxide and some amount of heat is produced. Whereas in the side of endothermic, there is an example of barium chloride. Barium hydroxide plus ammonium chloride will give you barium chloride plus water plus ammonia. In this reaction, the temperature falls. So it's endothermic reaction. Then we will go to change in color. Change in color. So here I give the example of potassium permanganate plus citric acid. So they will form permanganic acid and potassium citrate, where the color of the reactant is purple, but the product becomes colorless. As there is a change in color, you can confirm that the reaction has taken place. The last one, change in state. Here is the example. Wax melts down and provides you with water and carbon dioxide, means the solid state converts to liquid and gaseous state. So you got a basic idea. Do prepare with this. I will send you the notes with it. Write it down. If you have any doubt, do ask me. Thank you.